As mobile developers, the way we write a code matters just as much as features we build. Clean, readable, and maintainable code saves time, reduces bugs, and keeps projects scalable. Today, I'll share 20 professional code practices with examples from Flutter that will level up your code quality immediately. When naming variables, functions, and classes in Dart, always choose meaningful names that clearly describe their purpose. Avoid abbreviation or vague terms. Clarity always beats brevity. For example, instead of using DT, which doesn't explain anything, use last login date. This makes your code easier to read, understand, and maintain. 2. Short functions. In Dart, your function should be small, focused, and do just one thing. If a function starts handling too many tasks, split into smaller functions. For example, instead of having a big process order function that validates, saves, and sends to an email, create a separate functions like isValidateOrder, SaveOrder, and notifyUser. This makes your code cleaner, easier to read, test, and maintain. Functions should be small, focused, and do one thing. If it's getting long, split it up. 3. Single responsibility principle. A class or function should have only one reason to change. Don't mix unrelated responsibilities in the same place. Keep your code focused and organized by separating concerns. This class is handling two responsibilities, managing users and sending emails. If the email logic changes, we modify this class. If database logic change, we modify this class again. So, the one reason to change is broken now. That breaks is RB. Why it's better? User responsibility only manage user data. Email service only manages emails. Each class has one responsibility, cleaner, easier to maintain. 4. Avoid deep nesting. Too many nested ifs make code hard to follow. Use early returns or a guard clauses. 5. Remove dead code. Dead code is any piece of code that is no longer used or needed. This includes unused variables or functions that are not called anywhere. Comment out blocks from old experiments or features. Unused imports from packages you no longer use. Old files that are never onboarded or referenced. Why remove it? Dead code wastes mental energies. Other developers may think it's still important. It bloats the code base, makes search and navigation harder. In some cases, unused imports or code can slow down builds. It can confuse future maintainers about what's actually in use. In Dart and Flutter, the Dart Analyzer flags unused imports and variables. Flutter Analyze in terminals show them. Most IDE have a remove unused imports action. We use CI checks to prevent dead code from being committed. 6. Minimal side effects and pure functions. A function should not unexpectedly change external states. If it's pure, the same input always gives the same output. 7. Function arguments. Too many parameters makes functions harder to use. Group related ones onto objects. 8. Keep classes small. A smaller class is one that does one job and does it well. When a class grows too big, it becomes a giant class, knowing too much, doing too much, and controlling too much. Why keep classes small? It's easier to understand. You can read the entire class without scrolling forever. Easier to test, and smaller classes have fewer dependencies. Easier to maintain. Changes are isolated to specific part of the code. Encourage usability. Smaller classes can be combined in different ways. In Flutter, big classes often happen when a widget class handles UI and business logic. Services mix multiple responsibilities. Models have too many unrelated properties. 9. Composition over inheritance. Inheritance lets you create new classes based on existing ones, but deep inheritance trees can make your code rigid and harder to change. Composition means building functionality by combining smaller specialized objects instead of extending from apparent classes. Why prefer composition? More flexibility, you can swap out your component without affecting unrelated code. Avoid fragile base class, problem where changes in parent class break child classes. Encourage small, reusable components. In Flutter, mobile apps composition is often used to inject dependencies like services or repositories into classes. Create widgets by combining smaller widgets rather than subclassing existing ones. Share behavior without forcing a fixed class hierarchy. Here you go, example inheritance, less flexible. Problem if you need to change how drawing works or add behavior from another unrelated shape, you are stuck with a class hierarchy. Example, composition more flexible. Now you can swap render for another implementation without touching the circle. 10. Write unit tests for logic. Unit tests focus on small isolated pieces of code, usually a single function or a class, to make sure they behave as expected. In mobile apps, UI tests can be slow and fragile, but logic tests are fast and catch issues before they reach to the UI layer. Why test core logic? Detect bugs early before they break the app in production. Give you confidence to refactor without fear. Save time. Running unit tests takes seconds compared to manual testing. Document intended behavior for other developers. For Flutter, use test package. Keep tests in Flutter tests/directory. Focus on business logic, not widget layout. That's for widget tests. Example, business logic without tests. It's risky, right? If someone changes apply discount incorrectly, you'll not know until it breaks in the app. Here you go, an example with unit tests. It's safe. Now, if someone changed the formula incorrectly, that test will fail immediately. 11. Test edge cases. Most developers test the happy path, the scenario where everything goes right. But in the real apps, users make mistakes. Devices run out of their memory, APIs fails, and the weird input happens. Edge cases testing is about checking how your code behaves under unusual or extreme conditions. First, invalid inputs like null values, empty strings, special characters. 2. Boundary values, smallest largest allowed number, empty lists, maximize capacity. 3. Unexpected states, expired token, disconnected network, corrupted data. 4. Rare condition, leap years, daylight saving, time zone shifts. Testing this ensures your app fails gracefully instead of crashing. Here's an example without edge cases. 12. Try, don't repeat yourself. Repeating the same code in multiple places might seem convenient, but it quickly becomes a headache. Why avoid duplication? If you need to change something, you have to update all copies, risking bugs if you're missing one. Duplicate code, bloat your code base, and makes it harder to read. It hides common patterns that can be extracted and reused. Instead, extract repeated logic into functions, classes, or utils. In Flutter apps, this often means moving repeated UI widgets into reusable components, creating helper functions for common calculation or formatting, centralizing network calls, or error handling logic. 13. Keep it simple. KISS stands for Keep It Simple, Stupid, a reminder to avoid unnecessary complexity in your code. Why keep it simple? Simple code is easier to read and understand. It's less prone to bugs and easier to debug. It allows faster development and easier maintenance. You can always add complexity later if needed. Start simple and iteratable. In Flutter mobile development, this means don't prematurely optimize or add features that are not required yet. Choose a clear, straightforward solution over clear, complex ones. Use basic widgets and patterns before introducing complicated architecture. 14. YAGNI. YAGNI reminds us to avoid building features or code for hypothetical future needs that might never actually happen. Focus on what's needed today and add complexity only when it becomes necessary. 15. Fail fast. Fail fast means catch problem as earlier as possible. Validate inputs and throw errors right away instead of letting bad data silently cause bugs later. In Flutter, use assertion in development. Validate API responses or user input immediately through exceptions with meaningful messages. 16. Graceful error handling. Errors and exceptions are inevitable in software. What matters is how your app handles them. Gracefully means preventing crashes and giving users clear feedback. In Flutter, use try-catch blocks around risky code like network calls. Show friendly error messages or retry options. Furthermore, log errors or diagnostics without exposing sensitive info. Use error boundaries or widget like future builders error handling. 17. Avoid magic numbers and strings. Magic numbers and strings hide intent and cause maintenance headache. Replace them with named constants or enums. This clarifies your codes and makes changes safer and easier. In Flutter, use const variables for fixed values and use enums for meaningful groups of values like user rules and states, etc. 18. Immutable data structures. Favor immutability, it's safer and prevents accidental changes. In state management, especially block, mutating objects after they have been emitted can lead to unpredictable behavior. The UI may not rebuild because the equal comparison think nothing changed. Debugging becomes harder when state history is not reliable. You risk introducing subtle bugs when multiple parts of your app share the same reference. In Flutter and Dart, mark fields as final so they cannot be reassigned. Use const constructor for compile time immutability. Instead of modifying existing lists or maps, create new ones with updated values. 19. Self-documented code. Write code that explains itself, fewer comments needed. No comment is needed because the method name and the parameters tell the story. 20. Comment why, not what. Commenting in code are not for translating what it does, but for explaining why it was written in this way. Example, good commenting why. Example, bad commenting what. These comments just repeat what the code does, they add no value. Example, good commenting why. These comments explain intent trade-offs and where to look for related logic. Example, when a comment must explain a workaround. Include the issue ID or the link so future devs can verify whether the workaround is still required. Example, document comments for public API. This documents behavior edge cases and the reason for retries. Follow for more programming tips.